All right, good morning, Fine Science 2. Okay, this is only the first lesson in this week because Monday was holiday, so we don't have lesson. So in this week, we have only one lesson, which is on today, Wednesday. Okay, so you know why the reason I want you all to present, because if I don't ask you, I don't force you to come to join the lesson to do revision, you all are too free or outside there. Okay. I always remind you all the self-discipline is very important now. During the time like this, self-discipline is very important, because you don't go to the school, right? Like nobody guide you, so you have to be very good self-discipline yourself. Okay, arrange your time to study at home, online lesson carried out by your school teacher. You must attend, focus, and you are attending tuition outside. You have online class in tuition. Also, you must attend. Okay, discipline is very important. Other than that, always spare some time for yourself to study at home. That's very important. Okay, this is a time for really now for you to get it ready for yourself for your SPM. Okay. Right. Okay, now I want to start doing revision using full format SPM question, as I told you in the WhatsApp group, right? Okay, the module I given to you in the school one are all are very short question. They're not full format SPM. That one you can use it for your self revision. Okay, but for online class, I want to use a full format, the full questions of the SPM format. Okay, so I start with lesson 1. This is set 1. Set 1, I hope every one of you print out the paper. If you haven't print out, don't worry. You just copy down the answer today. You can print out later. Okay, so I start with step 1. I share with you the paper now. Okay, can you all see the paper? Can see or not?
Yes, sir.
Can see, Anik, thank you. Okay, can see. Right, this is a paper. This is question number 1. Okay, come. This is your Form 4, Chapter 1. Okay, Chapter 1 question. Come, let's go through the question first. Okay. Diagram 2.1, this diagram show the reading of measuring instrument. This is watt meter. You can see there's a V, so this is watt meter. When switch is open, open means off, it's not connecting. Not connecting means not supposed to have any reading wattage here one. But how come the pointer is showing some reading here? Okay. Why? You see, I'm not connected, but the meter gives some reading. This is something wrong already, right? Something wrong with this watt meter. What is the error?
Zero error.
Yes, very good, Fasli. This is zero error. If no reading because disconnected, right? Supposed to point to 0. But now it never point to 0 means this watt meter is having some error. This is called zero error. Okay, Then diagram 2.2 show the reading. Okay, 2.2 is here. I make it bigger. Sorry, slowly. Okay. Diagram 2.2 shows the readings of measuring instrument. Okay. When the switch is closed, and now you see the switch is on, there's a reading of wattage already, right? And then it shows the reading. So this is a reading now. But since this watt meter carry zero error, that means this reading is not accurate one, So what you need to do is you must take this reading minus zero error, correct? Not do correction. Okay, Okay, now first question, very simple. What is the physical quantity measured by this instrument? This instrument measuring what?
Voltage.
Wattage. Yes. Another better term for wattage is what? Besides we say wattage, there's another better name, What is the answer?
Electricity.
Huh?
Electricity.
Electricity. No. This Barack Obama give the correct answer already. Richie also give the answer. The answer given by Al and Richie, your answer correct. Very good. So the answer is okay, come I show you the answer lah, huh? Potential different. Okay. In fact, the right terminology is potential different. Okay. We don't say wattage lah. Wattage is too brief, you know. So use a better answer. We say potential different. When it's potential different. Okay, actually now, since from 4, from 5, right? You all must learn the right terminology lah. We don't use wattage anymore, you know. It's supposed to be potential different. Okay, got it or not? Yeah, potential different. But deep in your heart, you must know lah. Potential different is wattage. But when you answer the question, you don't write wattage, you know. You write potential different. Got it or not, everyone? Sanjeev, do you understand?
Yes, sir.
Okay, next question.
Yes, sir.
Okay, thank you. Types of zero error are these types of zero error. Okay, zero error got two, you know. One is positive, one is negative. Do you remember or not?
Yes.
Got positive zero error, got negative zero error. Then you look carefully this one. This one's supposed to be positive or negative. How you determine positive or negative? Ow. Wow, ow, your microphone very horrible. Okay, now let me explain to you that this you can look at this one. Before you measure anything, already show the reading already 0.1. So meaning that this 0.1 have to be minus, you know. How can you off your mic? Off your mic, please. Your mic I off for you lah, cannot. How can you off your mic? Yeah. Okay. Before you measure anything, already show the answer 0.1. So meaning that when you do correction, you have to minus 0.1. So minus 0.1 means the zero error must be positive or negative. Positive or negative should be when you do calculation, correction you minus the reading minus zero error. So your zero error in this case would be positive or negative.
Positive.
Yes, positive. It should be positive because when you minus a positive value, minus positive means you minus, isn't it? When you minus negative, it becomes plus, correct or not? Understand? So you want to minus it, so this one should be positive zero error because when you minus positive, it becomes minus. When you minus negative, negative become positive. So that's not right. So you know the answer already. So types of error here is positive zero error. Come, let's see the answer. Positive zero error. It should be positive. Positive zero error. Okay. Positive. Okay, next. Next one is, what is a value? A value, you already know lah. This is, what is a value here? You see carefully. Here is 0, here is 1. I think it should be 0.1, no? Correct not? So the answer 0.1 word. Okay, is 0.1. Positive 0.1. Okay. All right, next question. Next question is, what is a reading shown on diagram 2.2? Okay, hold on. Let me pick out a pen first. Okay, one moment. Okay. What is a reading show on diagram 2.2? Mean this diagram lah. What is a reading? This one here. What is this reading? Okay, please read carefully, everyone. It's 1 point something, right? So what is the reading here? Cha, what is the reading? Cha. Cha Kai Kwan.
You
Chala,
want to
what is
count
the
the
reading?
zero error or not, sir?
No, they're asking the reading only. This reading is how much?
1.1 volt.
Yes, correct. It's 1.1. Okay. 1.1. Okay. So the reading is 1.1. 1.1 is shown on the diagram. 1.1 volt. Okay, next. Next, I believe they ask you to do correction. No? What is the value of zero error? Done already. Okay. What is the actual reading? Actual reading, then only you minus the zero error. Okay. So take the reading just now minus the zero error. Anik, what is the answer? Anik, what is the actual reading? Huh? Chan Yijin, what is the actual reading? Chan Yijin?
1.0
Yes, correct. How you get it? How you get 1.0?
minus the zero error.
Yes, correct. Very good. Thank you, Chan. So you get this answer. You take your reading 1.1 minus the zero error, minus positive zero error. That's why you get 1.0 volt. Okay, so this question you must get full marks. Understand? When you have this kind of question, you must get full marks. Do it carefully. Okay. Okay, come. We move on to the next question. This is chapter 2. Chapter 2 is force and motion. Is you learn inertia, momentum, this kind of thing in this chapter 2, right? Do you remember or not? Okay, come. Diagram show a baseball player wearing a soft tip glove. This is a glove wear by the baseball player to catch a ball during the baseball match. You see now, to catch the ball, the player must wear a glove. The glove usually is very soft. You know the reason, right? It's something to do with impulsive force, right? This one is soft material. Okay. Now the question, what is meant by impulsive force? Impulsive force is what? You see here the format. The question always started with definition 1, rate of change of momentum. Yes, Shakira, you are very good. Rate of change of momentum. Okay, Shakira, thank you. Okay, so the answer is rate of change of momentum where the time of impact is short. Usually for impulsive force, the time of impact must be very short one. Okay, so it's a rate of change of momentum where the time of impact is short. Okay, that's the answer. In fact, you just write rate of change of momentum can already. This one is just an additional one. You write this one can already. This one is an extra one. The rate of change of momentum means rate of change means change in momentum divided by time. That's all. Okay, mv minus mu divided by time. Time is the impact time. Okay, that's the formula. Okay, next. The ball mass 0.15 kilo, move with a velocity 20. When it hit now, so the ball move with velocity 20. Calculate the impulsive force acting on a glove when the time impact is 8 times 10 power negative 2 seconds, very short time. Okay, you see now, the mass of the ball 0.15. The moment the ball is hit, the velocity is this one. So this is an initial velocity. When it hit the hand, right? When it hit the hand, so it will stop, it will stop. So the final velocity is supposed to be 0 because when it reach the hand, it will stop, right? So final velocity is 0. Impact time is this one. So can you calculate the impulsive force? Okay, can someone suggest a formula? What formula to use here to calculate the impulsive force? Seem very quiet here, no? My size not used to be very quiet one this class. Cheryl, Cheryl, can you tell me what formula can be used here? Shearer Teo. Shearer, she say Ft equal to mv minus mu over time. Yes, this is new. New give answer. New, you are right. Okay, come. Let's see the formula. This is a formula. Okay, mv minus u over time. Okay, mass change to a kilogram 0.15. Final velocity 0, as I told you just now. When the ball hit the hand, it stop. Right? Initial velocity 20. Time 0.08. This is 0.08 second. Okay, when you change to number. So you get negative 37.5 Newton. That's the answer. But I want to ask you, why the answer is negative? Why the answer negative? Anik, why the answer negative? Anik,
Yes, sir.
why the answer is negative? The answer negative 37.5 Newton. The negative show what, Anik? When your hand catching the ball, so the impulsive force is negative. So negative show what? Anik? Adi?
The opposite direction, sir.
Yes, correct. Anik, you are right. It shows that now the impulsive force, right, acted in opposite direction. So your hand like this, so it acted against your hand. So it's negative lah. Yeah. Okay. So next. This one settled already. Now they ask you to compare. Compare the impulsive force in the baseball where a hard glove, the player wear a hard glove. How do you think? Just now the glove was very soft. Now you say the baseball player wear a hard glove. So what happened to the impulsive force? And explain your answer. But never try wearing a hard glove to catch the ball, no? Yes, Richie, you are right. Higher force. The impulsive force become higher. Yes, Vanessa, you are correct. Impulsive force increases. Very good, Vanessa and Richie. And some more. Short time impact. Yes, Vanessa, you are right. Okay, thank you very much, Vanessa. So the answer is here. Larger impulsive force due to shorter time of impact. Because when now the glove is hard means hard surface. So the contact time becomes shorter. When the contact time is shorter, the impulsive force becomes bigger. Okay, you know that, right? The formula. The time becomes shorter. You divide by a smaller number, so your answer becomes bigger. So the impulsive force becomes larger because shorter impact time. Okay, shorter times of impact. Okay, I feel very disappointed because Amalina not here. No, what is the problem with her? She don't have data or what? Amalina here or not? Amalina. Patricia is here already, right? Where are you? Patricia, I see your name already. You are here. Good. Okay. Amalina not here yet. Okay. Now mind we go on now. Okay. The next question, number 7. This one is still chapter 2. Okay. Chapter 2, motion. This is motion. A student running a 200-meter event. 200 might see the distance. Total distance 0 to 200. So the event is 200 meters. Diagram show the distance time graph. This distance against the time. Elastic is running, meaning that this boy now finish a 200 meters using 24 seconds. I don't know the time now. 24 seconds maybe for world record. I think it's too long already. Very slow. World record for I think for 200 meters is less than 20 seconds one. Okay, very fast one. Okay. So never mind, we just focus on this question. So finish 200 in 24 seconds. Okay. You see this point, how he run, at first consider slow, here slow. Then the final 100 meter, he pick up faster lah. From here, you know already, the gradient picker means the point run faster. Here, he started with very slow. The first 100, he run very slow. In fact, he used 14 seconds to finish the first 100 track. And then the second 100, he used only 10 seconds, 24 minus 40, 10 seconds to finish. I mean, he started slowly, then after that, he speed up. Okay, this is how he run, Okay, now the question. Which one is correct? Take the correct answer in the box. The distance is what quantity? Scalar or vector? Distance is which what quantity?
Scalar.
Yes, scalar. Very good. Michelle Chuang, correct. You are correct, Michelle. You say scalar. So the answer is scalar lah. This one, so you cross here. Scalar quantity. Okay. In fact, what is the meaning of scalar quantity? Class?
Have direction, no magnitude.
Possibly say it again.
Have direction, no magnitude.
Ya kah? Kimberly now only come in. Okay. Okay, scalar quantity is, okay, someone keep the answer. Let's check. Ping Yi say what now? And then Ping Yi say, got magnitude only. Then Michelle Chua say, does not have direction. Yes, correct. Okay. So meaning that now scalar quantity is a quantity with magnitude only, but no direction. Understand? Got magnitude but no direction. That is called scalar. Okay. Whereas a vector quantity is what? Vector means you have both lah. You have magnitude, you have direction. It's called vector quantity. Okay, come, let's move on. Someone microphone is not off, who is that? I can hear the mother shouting behind. Based on, okay, now Ashia coming. Based on diagram, calculate the speed of student at section AP. AP means here only, this part. To find the speed. How to find the speed? AP here, lor. To find the speed, you to find the gradient, no? You take the distance divided by time. Okay, find the gradient now. Speed. Speed is distance divided by time. Okay, like that, lor. Actually, it's finding the gradient now. Distance is here. Distance is 100 meters. Time 10 seconds. So you find the gradient, you find the speed. Correct not? Okay, do. Okay, I give you 1 minute. Everyone calculate. What is the speed AP? What is the speed here? Okay, please do it now, everyone. Calculate the speed.
10 meter per second.
10 meters per second. Okay, let's check the answer now. Yes, correct. You are right, Fazli. Okay. So the gradient is 200 minus 100 divided by the time, 24 minus 14. Okay, you get 10 meters per second. So make sure your unit is correct, meter per second. All the answer given in the SPM, actually the unit must be correct. The unit is given 1 mark on you get 10, but your unit is wrong, also minus marks on, Yeah, understand this, everyone? Speed AP, you get this answer now. Find the gradient now. 200 minus 10, 200 minus 100. Divided by the time. Time is 24 minus 14, so it's 10 meters per second. Okay? Got it now, everyone? Pong, do you get the answer? Pong, Pong Jelly.
Yes, sir.
Yes, yeah, you say yes so many times, Pong. Okay, come. Next. Next question. Compare the speeds of student at OA, AP. They want you to compare, you know, OA, AP. Okay, mean here, lor, here and here. Okay. Actually, you already know the answer lah. Just now I told you already, right? Here the speed is 10. What about the speed here? You can calculate now what is the speed here. Here is 10. Then here is 100 divided by 14. Should be smaller lah. Correct not? Find the gradient 100 divided by the time 14. Okay, everyone, 3, 2, calculate this speed, and then only you answer lah. You compare A, B, O, A, who is faster, who is slower. Okay, do it now. Everybody do. For those who just came in, send your attendance, type present and send. Kimberly, type present and then send in the chat box, okay? Now Sanjeev send again. Kimberly send, okay, thank you. Many of you haven't sent one. So let's check the answer. So the answer is like this. Now, speed at OA is 100 minus 0 divided by the time 14 minus 0. So you get 7.14. Just now was 10. Now here only 7.14. So the conclusion is AP higher lah. Speed at AP is higher. Okay, 1 mark only. Speed at AP is higher. This one 10. This one only 7.14. So the AP speed is higher. That's the answer. Okay, got it? Almost everyone here already. I think got 2 only, and one is Amalina not here. Another one is who?
Kuhan.
Don't simply change the name lah. What Mr. Tam grandson? Okay, come. Let's move on. Then someone please help me to identify beside Amalina, who else? Got one more person.
Kuhan.
Guhen and Amalina. Anika, can you help me to inform Amalina? You tell her no must attend the class, Anika.
Sir,
Yes.
I called her already.
Then what she answer?
She said okay.
But never come in, no.
I don't know.
Sanjeev, you inform Guhen, please, Sanjeev.
Okay, sir.
Then you tell him must join the lesson online. Okay. All right. Next.
Okay, sure, sir.
Yeah. Thank you. Okay. Next question. Based on the following aspect, give this kind of question you will get this kind of format. Okay. Give suggestion on how the running time for the 200 event can be shortened. That means you must suggest make the boy run the 200 meter in shorter time, means run faster. Okay. First one is the attire. Give suggestion and give the reason. What kind of attire the boy must wear? Okay. What is the reason? And then what kind of shoes the boy must wear? Give reason. 4 marks. This is kacang. You must get the correct one. Think of it. Everyone, what kind of attire? The shirt, how? And I want the shoes. Yes, Shakira, you are right. Tight attire. The attire must be tight. Tight one. Reason is what, Shakira? Why must wear tight? I know Shakira is a runner. I know. I saw her run in the school. Why must be tight attire, Shakira?
No, you look.
Yes, correct. Reduce air resistance. Very good. Okay. Yes, can reduce the air resistance. What about the shoes? Shoes, how? Spike. Wearing a spike. Correct. Wearing a spike. Spike, but you cannot say spike. You must say the shoes. The sole. S-O-L-E. Tapak kasut. The sole of the shoe must have what? Like paku-paku one, you call what? In English, we call it what? The shoes or the sole of the shoe must have what?
Clip.
Yeah, stud. S-T-U-D, stud, okay? And then the reason is what? Why the shoe must have the stud? What is the reason? Better grip. Yeah, Shakira, yeah, very good. I can see, Shakira, you improve a lot, you know. So keep your momentum, Shakira. Okay, come, let's check the answer. The answer is here. The attire must be tight and light sport attire. Tight and light, you know, must be light also. Tight and light. The reason is reduce the effect of air resistance so that the speed can be increased. Reduce the effect of air resistance now, increase the speed. This one is just for, this one only copy this one just for your knowledge only. You copy the first two sentences can already, okay? And the shoe, the sole. Sole means tapak kasut, okay? The sole with studs must have studs to ensure a better grip on the ground to prevent falling. Okay, that's the answer. Có đi answer now? Got all the answer, please. Okay, finish or not, class?
Finish.
Finish, Okay, Chan finish. Okay, come, let's move on. The third one they ask, equipment used at starting line.
Use starter block.
Yes, to use starting block, right? Starting block. What is the reason using the starting block?
For thrust.
Thrust. Yes, correct. Because the starting block, when you kick on the starting block, you have a stronger force to start the event, right? Starting block. Okay, come to check the answer. Starting block to increase the acceleration. The reason is the starting block can increase your acceleration. You have stronger thrust. Stronger thrust means that you can accelerate faster. Use starting block to increase the acceleration. Okay, this one finished. Okay, next one. Next question. This is chapter 3. Chapter 3, I think, no, we skip this one first. Okay. The one I marked with the red color, this one. Okay. The The question we skip, I will go back. I will come back later lah. For today, I want to do this one first, chapter 4. Okay, please look at this question. Then follow this question. Diagram show a metal P. This is a metal 100 degrees Celsius. Means this boy is very hot one, 100 degrees Celsius and then immerse into the water. So it will heat up the water lah, definitely. Place in a bigger water temperature. This water temperature only 28. So this hot ball will release the heat to heat up the water lah. After a few minutes, thermal equilibrium. I'm sure they will ask you one. What is the meaning of thermal equilibrium? The format SPM, standard one. Sure they ask definition. After a few minutes, thermal equilibrium state is achieved. Diagram 3.2 show temperature against time. This is temperature. This is time. Okay. Okay. Now you can see from here lah. The water temperature started with 28. When you put the ball 100 degree one inside the water, you see the water temperature go up now. 28, 30, 35. Then finally reach 40 degree. When the water temperature reach 40 now, so the temperature become constant. Constant means the temperature, the water and the ball achieve thermal equilibrium now because the temperature become constant already. So this 40 degree means it's a water for both, water and also the ball. The temperature stay at 40 means balance already, equilibrium already. Okay. All right. Now the question. I see. I told you already. The standard one, sure they ask like this one. What is the meaning of thermal equilibrium? No heat transfer. A net heat transfer 0. Yes, New, you are right. Ping Yi, rate of heat transfer becomes 0. Yes, Ping Yi, you are right. Okay, come see the answer. No, here, the answer here. Thermal equilibrium means rate of heat transfer between the bodies are the same. Rate of heat transfer becomes the same. Same means it becomes 0 lah. Another meaning means the rate of heat transfer is 0 lah. Because from left go to right, right go to left, the heat transfer becomes the same. So when you minus, you get 0. Okay. And of course, the temperature of the two bodies become the same. At 40 degrees, become the same lah. So you can give either one of these answer. Okay. You say rate of heat transfer become the same, or you say rate of heat transfer become, if rate of heat transfer become, cannot say 0, If you say net rate of heat transfer, then you can give 0. Okay. Net rate of heat transfer 0. If heat transfer not 0, same only, left to the right, right to the left, same. But when you say net heat transfer is become 0. Net means you minus lah. Okay. Another one answer you can give is both of them having the same temperature lah. That is the meaning of thermal equilibrium. Okay. Yeah, this one done already. The next. What is the temperature when thermal equilibrium? Actually, this one very simple, 40 degree. From here, you know, right? 40 degree. Okay, right? 40, that's all. Okay, 40 degree. What is the purpose of wrapping the beaker with cotton? You need to wrap with cotton here, you see? Why you need to wrap it with cotton? I think reduce heat loss. Yeah, Shakira, you are correct. Okay, so the answer is prevent heat loss to the surrounding. Okay, prevent heat loss to the surrounding. That's why you wrap it up. Yeah. Okay, next question. Calculate the specific heat capacity of metal P. Calculate the specific capacity means find the C value for metal. Okay, tips are to answer this question, right? You must say heat released by the ball equal to heat absorbed by the water. Then you start writing like this lah. Heat released by the metal ball equal to heat absorbed by the water. That's you start from there. Heat absorbed, heat released must be the same. So both also MC theta, correct not? But you put 1 and 2 lah, differentiate them. So M1 C1 theta 1, M2 C2 theta 2. Okay, you start with that. Try. Okay, I'll give you 1 minute to try first. Okay, I need to go to the washroom a while now. Okay, excuse me. Okay, sorry. Okay, anyone here get the answer? Anyone got the answer or not? Anyone? Try. Cha, you got the answer or not? Cha, do you have the answer? Tan Yin Si, do you have the answer? Tan Yin Si? Okay, no one answer me. Anyone got any answer or not?
Which answer which one? A number what?
This one, the calculation. What is the specific capacity of metal P? Anyone got the answer?
2520 joule per kilogram per degree Celsius.
25 what? Firstly? Say it again, firstly. 2,500 something. Okay, never mind. Let's check the answer. No, the answer is 420, 420. Now, mind check where you make mistake firstly. Good try. Thank you, firstly. Okay. The answer should be like this, you know. I don't know whether this answer is correct. Everybody please check. Heat supplied by the metal equal to heat absorbed. Both also same lah. MC theta, put 1 and 2. The ball 0.4. Is it 0.4 kilogram? Where got mentioned 0.4 kilogram? Yeah, got here 0.4. Okay. So the ball 0.4. C you don't know. Change in temperature for the ball is 100 minus 40 because final temperature is 40 ma. Initial temperature of the ball is 100, so change drop by 60 degrees lah. So 100 minus 40. And then for the water, 0.2 kilo. I think got mentioned in the question, right? The water 0.2. Yes, correct. Okay. Specific capacity of water 4,002. Change in temperature of water 40 minus 28. Initially the water 28 degree ma, finally become 40, so change you minus. Okay, you calculate like this, you get a C. Can someone take a calculator, check this answer correct or not? Please Check the answer. Is it correct? $420.
Correct, sir.
Correct. Okay. Thank you, Brendan. Okay. So the answer is 420 joule per kilogram per degree Celsius. 2 marks. Fazli, where you make mistake, Fazli?
Math terbalik.
Oh, Math terbalik lah. Read the question carefully, Okay, done, Okay, next. Number 7. Same types of question, heat. What is meant by, what is meant by specific heat capacity? Same answer like just now, okay? You can copy the same answer now. Specific heat capacity means same answer, okay? Amount of heat required to raise the temperature of 1 kilogram of substance by 1 degree. Amount of heat start from here, Amount of heat required to raise the temperature of 1 kilogram of substance by 1 degree. It must be 1 kilo, 1 degree because it's specific, okay? So this one, okay, This one should be, everybody should know already, lah. The next, a beaker containing 250 gram water, initially 26 degree, the temperature 26, heated with a 500 watt heater for 1 minute, just 1 minute only. The final temperature after 1 minute is 51 degree. Initial 26, after 1 minute heating, it becomes 51, very clear already, lah. Calculate specific heat capacity. Okay, these questions are, since the energy, the heat energy provided by the heater, so you take PT, power multiplied time PT, equal MC theta. Okay, use a formula. PT equal to MC theta. Okay, this one is power, PT. PT equal to MC theta. Come on. Power 500 times 1 minute change to second, 60 seconds. Mass 0.25 change to kilogram. Find the C lah. Theta, what about the theta? Theta is how much? Brendan, what is the theta here? Co-living,
Yes.
what is the theta?
25.
Kimberly already answered. Kimberly said 25. Yes, correct. 51 minus 26, 25 lah. Okay, So now check the answer. So MC theta to find C theta divided by M theta. Okay, 500. This one 1 minute change to second 60. Mass, then temperature 25. So we get this. Check this answer. Use a calculator to check see whether it's correct or not. 4,800. I'm not sure the answer is correct one. Please check.
Correct.
Correct, Fazli. Okay, thank you. Okay, we go one more part, so we stop. I know I want you need to rest before your next lesson. Okay, come a little bit more. A more accurate values of specific heat capacity water is 4,200. Is the calculated value bigger or lesser? The accurate one is 4,200, but our answer just now was 4,800 means our answer is bigger lah, correct not? Okay, so it's bigger. Okay. Our calculated answer is bigger. The standard one is 4,200, but our answer here 4,008, so it's bigger lah. Definitely they ask you what is the reason. Why your calculated answer is bigger? Eh? Last year I stressed this point a few times already, you know, when you were in Form 4. Why our answer is bigger one?
Heat loss.
Yes, correct, because heat loss. When heat loss, it will make our answer become not accurate, it become bigger because of heat loss. Okay, come. Heat is lost to the surrounding during the heating. This caused the rise in the temperature to be less than the expected volume. Rise in the temperature of water to be less than what is possible or what is expected now. The smaller increase in the temperature caused the calculated values of specific heat capacity to be bigger. Okay. You all know the answer, the reason now. Okay, come, let me explain a little bit to you now. Okay. To calculate the specific capacity, the formula is C equal just now. What already? Theta over M, Q over M theta. Okay. Q which is PT lah. PT over M theta. Okay. Okay, the reason now because heat loss, right, will cause the change in temperature become smaller. Theta becomes smaller. Theta change in temperature becomes smaller than the expected value now because heat run away. When heat run away, right, change in temperature become less. When this number is smaller, you calculate your specific capacity answer become bigger. Understand or not? Because theta is small, because heat run, so temperature increase become less. So this one small, you divide by a smaller answer, so your answer will become bigger. So it's normal, you get a bigger answer. Okay, huh? The last, step 1 modification to get better value. So what you should do to improve so that your answer to be more accurate. So how you do?
Cover beaker with cotton wool.
Yes, correct. Reduce the heat loss. Surrounding the beaker can be wrapped with cotton to reduce the heat loss. To reduce the heat loss to the surrounding, the beaker can be wrapped with or put in an insulating material such as thick cotton cloth. Okay. Okay, 11 something already, so I stop here now. Okay, class. Next lesson, what lesson you have?
Sejarah.
Sejarah, okay lah. So I better stop here lah. Okay, everyone got the answer already? Okay,
Yes,
come. Okay, Fine Science 2, thank you very much for follow this lesson. Okay, today very good. I feel very happy to have lesson with you all today. Okay, I said see you next Monday. Okay, okay. Take a break before your sejarah lesson. Okay, bye-bye everyone. Fine Science 2, bye-bye.
Okay, thank you, sir.
Thank you, sir.
Bye-bye.
Yes, sir.
Bye-bye, bye-bye. Okay, bye-bye.
Thank you, sir.
Thank you, sir.
Okay, bye-bye, bye-bye.
Thank you, sir.
Okay, bye-bye.